All right, we are going to be solving quadratic equations by taking square roots. Now that sounds a little scary and something you've never probably heard before, but a quadratic equation just has a squared term in it. So everything else we've done in Algebra 1 has been a linear equation because if you graphed it, it made a line. So just a plain x term makes a line. You will be working with quadratics a lot in Algebra 2, but there is a little bit we have to do with it now. All right, everything we're going to do is we'll be taking square roots in order to solve. So there's two steps. The first thing is to get your squared term all alone. So you might have to add, subtract, multiply, or divide, or some of both of those, some of more than one of those to get the squared term by itself. All right, so if you look at number 1, that's already done for you. You have just a squared term on one side and then a number on the other side. When you have that down to that, then you take the square root of both sides. You hope that you have perfect squares, but sometimes you won't, so you'll have to simplify your square roots. There is one other trick that we'll talk about as we're working on them. All right, so first one, remember when you take the square root of something squared, those two undo each other. Those are inverse operations, so that's how we get h by itself. And then we take the square root of 25. You should recognize that 25 is a perfect square. You also have your square root sheet. All right, so we think our answer should just be h equals 5. However, there is a little trick, right? When you think of something squared, that means something multiplied by itself. So you are thinking, what can I multiply by itself? What can I square to give me 25? Well, yes, 5 times 5 is 25. However, negative 5 times negative 5 is also 25. So every single one of these is going to have two answers, a positive answer and a negative answer. So you can either write it like this, or what you will most likely see is that you can put a plus minus sign in front of it. So that's what I'll write. That shows you positive 5 and negative 5, just a little bit less writing. So for number 2, the first thing we need to do, again, your job is to get this by itself first. So we need to get rid of 1/5. To undo multiplying by a fraction, we multiply by the reciprocal. So times by 5 over 1 gives us x squared times by 5 over 1, which is just 5. So x squared equals 25. So it'll be the same thing as number 1 for our answer, but again, you had to do some work to get that. Once you have the squared term, square root, x equals 5 and negative 5. So that's our final answer. Number 3, we have 2 times b squared, so we need to get rid of the 2. Divide by 2, b squared equals 98 divided by 2 is 49. Again, have that perfect square sheet with you. It'll make it a lot easier because most of these are going to have perfect squares in them. Not all, but most of them. If you can't, if you don't have your square root sheet or you want to use your calculator, you do have a square root button. So you would do square root of 49, gives us 7. All right, but again, it's a lot easier. Hopefully you know that one anyway, or if you just have your square root sheet. So square root, b equals 7 and negative 7. So I write out plus and minus 7. Again, if you'd rather write both of the answers with a comma like this, that's totally fine. Number 4, to get t squared by itself, I need to get rid of the 57. So I need to add 57 to both sides. T squared equals, that gives me 144. So again, you can use your square root button, or hopefully you have your square root sheet there, your perfect square sheet. 144 is a perfect square. The square root of that is 12. So t equals plus and minus, positive and negative 12. Again, what you're finding is what can you plug in to make this true. You can plug 12 in, but you could also plug negative 12 in to make that answer true, or make that equation true. All right, these next two are a little tricky because they're going to end up being fractions. This is why we leave everything as simplified fractions. So again, to get y squared by itself, first I need to get rid of the plus 7. So minus 7 from both sides. 4y squared equals 1. Divide by 4, divide by 4. We leave it as 1 over 4. We do not make it 0.25. No decimals allowed. You should realize that 1 and 4 are both perfect squares. For the ones we do today on your worksheet, both top and bottom, numerator and denominator, are going to be perfect squares. Obviously, that's not always true, but to make things a little bit easier, I made sure that was true. So when you take the square root, you can either do one big square root, but I would recommend doing a square root on each one separately. That was the property we looked at the other day. So y equals square root of 1 is 1, square root of 4 is 2, and then don't forget the plus or minus. So positive and negative 1/2 is the square root of 1/4. So everything is going to be left as a fraction if you need to. Number 6. First thing we need to get rid of is the 5, so add 5 to both sides. 81x squared equals 25. Divide by 81, divide by 81. X squared equals. You look to see if you can simplify that at all, but nothing goes into 25 and 81. So we just leave it. We do not make it a decimal. You should recognize that both of those are perfect squares. So we take the square root of each thing. X equals, don't forget the plus and minus. Square root of 25 is 5. Square root of 81 is 9. So plus or minus 5 over 9, and you'll leave it like that. Even if you get an improper fraction, so let's say those two were flipped around, 81 over 25, you would leave it as 9 over 5. So just leave them as simplified improper fractions. All right, so most of them are going to end up being integers, positive and negative whole numbers. Once in a while, you're going to get a fraction, but those fractions, top and bottom, should both be perfect squares. So you can take the square root and just get a nice fraction. These last two, you're going to end up with square roots as your answer. All right, so here's what those will look like. Add 12 to both sides. 7y squared is equal to 35. Divide by 7, divide by 7. So you think, well, those aren't perfect squares, but 35 divided by 7 actually divides. All right, so y squared equals 5. Square root, square root. Y is not a perfect, or 5 is not a perfect square, and there are no perfect square factors. So you just leave it as plus and minus square root of 5. All right, and the last one is probably the one that requires the most work. Add 6 to both sides. 2/3 n squared is equal to 8. Again, multiply by the reciprocal, so times by 3 over 2. N squared is equal to 12. 8 times 3 over 2 is 12. So now I take the square root of both sides. N equals, I like to put my plus and minus down right away so I don't forget. 12 is not a perfect square, but it does have a perfect square factor. So we go back to the very beginning, and you need to break this down into 4 times 3. All right, so you still have to check to see if you can simplify. Square root of 4 is 2. Square root of 3 is your final answer. All right, so you're either going to have integers, positive and negative whole numbers, or you might have positive and negative nice looking fractions, or you might have to have square roots left over in your answer.